In this video, we're going to do an introduction to quadratic functions. Now, a quadratic function is a function that can be written in the form f of x equals ax squared plus bx plus c, where a, b, and c are constants. And also, we don't want a to be 0, because if a is 0, we would really be missing this x squared term here. And we would end up with just bx plus c, which would be a linear function. Okay, so a can't be 0. Now, as an example, f of x equals 4x squared plus 7x plus 8. That is a quadratic function. There, the a is 4, the b is 7, and the c is 8. Okay, also g of x equals x squared minus 9x plus 3.75 is considered a quadratic function. Now, you might wonder, what about this minus 9 here? There's a plus up here in the formula. Well, we could think of this as really 1x squared plus a negative 9x plus 3.75. Okay, so the a would be 1, the b would be negative 9, and the c would be 3.75. By the way, it's okay to have a decimal. Okay, and the last one, h of x equals x squared plus 7. That certainly doesn't look like it has this form. And notice you're missing the x term, you're missing the bx, but you could think of b as being 0. So this is really like 1x squared plus 0x plus 7. Okay, so it is a quadratic function. Okay, the b is allowed to be 0. In fact, these next several examples are very simple examples. F of x equals x squared, it's really plus 0x plus 0. And then g of x equals 3x squared plus 0x plus 0. And negative 0.25x squared plus 0x plus 0. So these are real simple ones, but I've made tables of values for them. And I want to take a look at their graphs. How do their graphs differ? Okay, now the fact that you don't have any x term or a constant term means that all of these are going to end up going through the origin here, 0, 0. That's not true for quadratic functions in general. Quadratic functions in general could be way over here or down here somewhere, but these ones are all going to go through the origin. Their vertex is what it's called, will be at the origin. Okay, now the graph of y equals x squared is just this blue function. Okay, y equals 3x squared. How does that look different than just x squared? Well, it's thinner. It doesn't open as widely as x squared. It's kind of a steeper graph here. And in fact, that will be true for any coefficient a that's bigger than 1. Okay, is that the graph will be thinner than the graph, or narrower than the graph of y equals x squared. Now, if the coefficient were less than 1, like 1/2 or 1/4, it would open more widely than y equals x squared. Okay, be wider than that. Now, what happens if the coefficient is negative? Okay, like negative 0.25 x squared, negative 1/4 x squared. Well, the fact that it's 1/4 means it's going to open more widely than x squared, but the fact it's negative means it's going to open downward. Okay, it's really flipped across the x-axis. Okay, now I've summarized in the next note here, what I just said is that the graph of the quadratic function f of x equals ax squared plus bx plus c is a parabola. And if a is greater than 0, the parabola opens upward. If a is less than 0, right, if a is negative, the parabola opens downward. Okay, and that was the case for all of these. Notice all of these were special cases where we're missing the bx, or the bx plus c part. But even if you had the b and the c involved, it's always true that the graph will be a parabola. And if the a is positive, the coefficient of x squared is positive, it'll open upward. And if a is negative, it'll open downward. Okay, now if the absolute value of a is less than 1, that just means that a is between minus 1 and 1. The parabola will be wider than the graph of x squared. Okay, and if the absolute value of a is greater than 1, that means that if a is either bigger than 1 or less than negative 1. So for example, if it's 5 or maybe negative 5, well, in that case, the parabola would be narrower than the graph of y equals x squared. Okay, it'd be steeper. Okay, now we still, in these graphs up here, we just considered parabolas where we were missing. They're of the form ax squared plus 0x plus 0. Okay, but what about ax squared plus bx plus c? Well, this note down here applies to all of those, even the ax squared plus bx plus c. But the question is, how do we graph these? Okay, how do we find the graph of these? In particular, how do we find where the graph is positioned? Maybe the parabola would be over here. Okay, or maybe the parabola might look like this. How do we find where the parabola is positioned? We'll talk about that in the next video.